Okay, guys, so let's start putting some of all of these techniques together. Okay, and so for this review worksheet, I'm going to go ahead and work out all of the odd problems and leave the even problems for you. Now, one thing that's going to be really nice is that the even problems are going to be able to be solved very similarly to the previous problem on the page. So if I work out number one, okay, after I work out number one, you work it out with me, pause the video, and then you work out number two, because the steps and techniques that are going to be used are almost identical. Okay, just kind of switched up the numbers and the variables. So let's go ahead and start. Okay, so I have this expression negative 4m times the quantity 3n minus m squared n plus 8m squared n squared minus 1. Okay, so with order of operations, okay, it's going to always tell me to do, let's review it. So please excuse my dear Aunt Sally, okay? And so parentheses comes first, but it talks about what's inside of parentheses. When you're working with algebraic expressions, what's inside of parentheses might not always have to be simplified. Like here I have 3n minus m squared n. There's nothing I can do to simplify that. 3n and m squared n are not like terms, so I cannot combine them, okay? So there's nothing to do inside of my parentheses. The next thing that you would worry about would be the exponents. But once again, once you're working with algebraic expressions, some exponents can be simplified, like n squared. That squared is just going to that n, and there's nothing I can do to simplify it, okay? It's not like saying 5 squared and simplifying it to be 25. So there's nothing I can do there. Now let's move on to multiplying and dividing, okay? Now I do see some multiplication that can be simplified, okay? This 4m is multiplying this whole entire parentheses so that I can eliminate, I can simplify that, that multiplication by distributing that negative 4m to each pieces. And so that's what I'll do. So whenever you are multiplying algebraic expressions, you always want to multiply the coefficients and add the exponents of like bases. So if you don't see a coefficient, maybe it helps you to put the number 1 in front of terms that don't have a coefficient. And maybe if you don't see an exponent above a variable, it helps you to put the number 1 on top. And I'm sorry, those are kind of messy. You don't know, it's my stylus. Okay. Anyway, so it could help you to put a 1 on top of those. Okay, so negative 4m times 3n is going to give you negative 4 times 3 is negative 12. M times n is just mn. Okay, I can't add those exponents because those don't have like bases. Okay, now negative 4 times negative 1 is a positive 4. Okay, m to the first times m squared, I add those exponents, m cubed, and then I still have a factor of n, okay, even though I don't have anything to combine with that. Okay, so I simplified that. Now I'm going to go ahead and just copy down the rest of my equation. Okay, now let's see what we can do as far as adding these together. Okay, negative 12mn, I'm looking for a term that also has an m raised to the first and an n raised to the first. I don't have any, okay? Here again, the m to the cubed n, I don't have any m cubed n, okay? M squared, n squareds, I don't have any other one of those. So this is actually completely simplified, okay? Now, always make sure at the end, you check to see if you have like terms. Remember, like terms have the same variable raised to the same exponent, and those like terms could be combined. All right, let's clear that away. Oops. And I'm going to leave number 2 for you. It's very, very similar. And then I'm going to do number 3. Okay, so just like before, whenever we talked about, you know, what can you actually do as far as order of operations tells you parentheses would go first, but what's inside of both of my parentheses, there's nothing can be done, okay? There's several terms, but the terms aren't like terms, so I can't combine them. So I'm gonna move on to the first thing I can do, which is multiplying. I see that I have this whole parentheses times that whole parentheses, okay? So to do that, I'm gonna have to distribute. So I'm gonna first distribute this guy, okay? And then I'll distribute this one as well. And then after I'm done distributing, I'll make sure that I don't have any like terms that I can combine. So 5v cubed times v squared, it gives me a 5v, oops. Sorry, my pen. Gives me a 5v to the fifth, right? V cubed times v squared, you add those exponents. 5v cubed times negative 5v gives me a negative 5 times 5 is 25. I have 3 factors of v on my left and 1 factor of v on my right. So I have a total of 4 factors of v. And then 5v cubed times 6 is a positive 30 v cubed, okay? All right, now we'll move on to the negative 2v. So negative 2v times v squared gives me a negative 2v cubed. Negative 2v times negative 5v gives me a positive 10v squared. And then negative 2v times positive 6 gives me a negative 12v. Okay, so now I want to start combining any sort of like terms that I have. And so I always want to express my answers in what we call standard form of a polynomial. And that involves making sure that the highest exponent is expressed first. So I see that I have a fifth power, but I don't have any to combine with him. So it's just 5v to the fifth. Same with the fourth. I don't have any other fourth powers. So I'll have a negative 25v to the fourth. Okay, now my cubes, it looks like I've got something to combine. A positive 30v cubed and a negative 2v cubed. 30 minus 2 gives me positive 28v cubes. And then here and here, there's nothing to combine with those, so I'll still just write those down. Okay, and then this is my final answer. So number 4 will be done very similarly. All right, I'm going to work out number 5. Now, number 5 is a rational expression. It involves variables on the top and bottom of a fraction. So the first thing I want to do is, since division is very similar to multiplication, what I'm going to do is I'm going to break the numerator apart so that the denominator divides each piece, okay? Just like in multiplication, where you would have to distribute your outside term to each piece inside your parentheses, that's what I gotta do here. So I'm gonna write 12y to the 7th divided by 4y minus 4y squared divided by 4y plus 8y divided by 4y. Okay. Now, when we are simplifying each one of these expressions, we will divide the coefficient and subtract the exponents. So here I have 12 divided by 4 leaves me with 3. Y to the 7th divided by y, you just subtract those. And since this is y to the 1st, we'll have y to the 6th left over. Minus, well, 4 divided by 4 is just 1. And then y squared divided by y is just y. So I would have 1y, or just y. Plus 8 divided by 4 is 2. And y divided by y is 1. And 2 times 1 is just 2. So I'll leave it just like that. And that's my final answer. Okay, now pause the video and do number 6. Very similarly worked out. Okay. Number 7. So I've got a rational expression again where I have 2 terms on top and 1 on bottom. Now I do want to take a time to note that when you have rational expressions, you do always want to check the top and the bottom. Okay, that there's nothing you can do to simplify the top and the bottom before you start your division. Okay, and so in the previous example, there was nothing to do on the top or the bottom, okay, separately. So we went ahead and started dividing. Here again, if you notice on the top, I have two terms, but they're not like terms, so I can't combine them. So I'll go ahead and separate this. Divided by 3xyz minus 3xyz divided by 3xyz. And I'm sorry, guys, my pen, I think I need a new, replace the tip on it. Okay, so I have 9 divided by 3 gives me 3. X cubed divided by x, that's 3 x's on top, 1 on the bottom, so I'll be left with 2 x's. Y squared divided by y, I'll just be left with 1 of those y's. And then z divided by z is just 1. And 1 times all of this stuff down here is still 3x squared y, so I'm not going to write that. Now, minus. Well, 3 divided by 3 is 1. X divided by x is 1. Y divided by y is 1. And z divided by z is 1. So it's really important that we understand, guys, that we have several factors of 1 on this term, okay? In fact, everything simplifies to a factor of 1, 3 divided by 3, x divided by x, and so on. So do I have to write it? Do they just cancel each other out? Well, no. Here I got to cancel the z's out because 3x squared y times 1 is still 3x squared y. I still need to make sure that I write at least, at the very minimal, the factor of 1, okay, when I'm doing that. So be careful with that. That's always a very common mistake that you'll see. So on number 8, I'm pretty much guaranteeing you, make sure you write that +1 at the end. Okay, number 9. So in the previous 2 examples, I went ahead and split up my rational expression right away so that we had individual rational expressions with a monomial on top and bottom. And that was because, like I said, there was no simplifying on the top and there was no simplifying on the bottom to do. But now with number 9, if you notice, the top isn't just a string of terms, it's now a multiplication problem. So before you do any division, it's always important to make sure you simplify the top and you simplify the bottom. So I'm going to go ahead and distribute these guys, right? Because we have a binomial times a binomial. So 5x squared times 3x squared is 15x to the 4th. 5x squared times 2x is a positive 10x cubed. Negative 4 times 3x squared is negative 12x squared. Negative 4 times positive 2 gives me a negative 8x. Okay, so I'm going to go ahead and do 2 steps in 1. All right, I simplified the top, and then I'm also going to split up into separate rational expressions. Okay, so instead of rewriting that twice, I just split it up. Okay. All right, so the first thing you want to do is make sure you do look at your coefficients and either divide those coefficients or simplify that fraction. I have 15/8. Okay, 8 does not divide evenly into 15, and there's nothing I can do to simplify 15/8. So it will still stay 15/8. Okay, and then I have x to the 4th divided by x is x cubed. Okay, now plus, now 10 divided by 8, 8 does not divide into 10 evenly, but that is a fraction that could be simplified, right? What can you divide evenly into 10 and 8? 2. 10 divided by 2 is 5, 8 divided by 2 is 4. X cubed divided by x leaves me with x squared right on the top. Minus, once again, I can't divide 8 into 12 evenly, but I can divide out of 4. 12 divided by 4 is 3, 8 divided by 4 is 2. X squared divided by x is just x. Okay, and here we see this again. 8x divided by minus 8x divided by 8x is just 1. So this will be minus 1. Okay, and that's my final answer. All right, so I encourage you to pause and do number 10, guys. Okay, 11. So order of operations will tell me to always multiply before I add. So I have this multiplication going on and this multiplication going on. And then after I'm done with those, I'll add them together. Okay, so that's going to be my game plan. So let's take care of over here. So when I multiply these monomials, I need to multiply the coefficients and add the exponents of like with like bases. So -3 times -4 is a positive 12. U squared times u to the 4th is u to the 6th, right? You add those. V times v squared is v cubed, okay? So remember, if you don't see an exponent, that is like v to the first power. Okay, and then we have plus -5. This is just a 1, right? So plus -5. U cubed times u cubed is u to the 6th. V squared times v is v to the 3rd. Okay, now let's see if we can add these two terms together. We can only combine them if they're like terms. Remember, like terms have the same variable raised to the same power. So they both have u to the 6th and v to the 3rd. So they are like terms. 12 plus -5 is the same thing as saying 12 minus 5. So I have 7. When you combine like terms, the variables and exponents stay the same. And I'm done. Okay, 12, once again, very similar, guys. Okay, let's look at number 13. So when we are simplifying, we always, like I said, you do what's inside parentheses first. A lot of times there's nothing going to be done inside of parentheses with this, guys, okay? And then next, what you would do is exponents. Now, the majority of what we've seen so far, or all of what we've seen, we see just an exponent, okay, affecting a single variable, like this y squared. There's nothing you can do. That squared is just right above that y. Same with x to the 4th. But here, this exponent and this exponent is affecting several factors, okay? This whole entire term right here is being raised to the 3rd. So the -2 is being affected by the cubed, the x squared is being affected by the cubed, and so is the y to the 4th. So I'm going to go ahead and take care of those exponents that lie on top of a parentheses, okay? So when an exponent is on top of a parentheses, that means that you can distribute that into the factors of that monomial inside of there. So -2 cubed. Now be careful, you're going to be tempted to say -6, but -2 cubed means -2 times -2 times -2. -2 times -2 is a positive 4, times another -2 gives me a -8. Okay? Now, when you distribute x squared raised to the 3rd, remember you multiply those exponents. X to the 6th, y to the 4th raised to the 3rd, y to the 12th. Okay? Minus, so we have 6x y to the 5th raised to the 2nd. So 6 squared is 36. X squared is just x squared. And y to the 5th raised to the 2nd is y to the 10th. And then times, remember that little dot means times, x to the 4th y squared. Okay. All right. So what do we have left? We have a subtraction and a multiplication, right? Subtraction and multiplication. So which one do you do first? You multiply first. -36 x squared y to the 10th times x to the 4th y to the 2nd. Multiply coefficients, so you really just have -36. X squared times x to the 4th, you add those exponents, so I have x to the 6th. Y to the 10th, y to the 12th, you have y, or y to the 2nd, you end up with y to the 12th. So we still have -8x to the 6th, y 12th. Okay, now I can do the subtraction. And the only way you're going to be able to combine these is if they're like terms. I see that they do have the same variables raised to the same coefficients, so I'm going to be able to subtract them. -8 combined with a -36. Okay, you add those values together and you get -44 4 x to the 6th y to the 12th. I really like this problem because you saw the power rule, right? When you have a power raised to a power, you multiply exponents. We saw the product rule. When you multiply exponents with like bases, you add the exponents. And we saw what it's like to combine like terms, how the exponents remained unaffected, okay, that they stay the same. So you see, when do you multiply them? When do you add them? Or when do they stay the same? And we saw all three of those there. Okay, so number 14 will be extremely similar. And let's move on. So I have a rational expression. You do want to make sure that when you have a rational expression that the top and the bottom are simplified. So I have 3a cubed b all raised to the cube. So since that exponent, the cubed, is above a parentheses, I know I can distribute that to the different factors. So 3 cubed is 3 times 3 times 3, which is 27. A cubed raised to the cubed is a to the 9th. And then b cubed is just b cubed. Divided by 3 squared is 9, a squared is a squared, and b squared is b squared. So when we simplify, we want to make sure that we divide or simplify the fraction of the coefficients. 27 divided by 9 is just 3. I'm going to write this off to the side. A to the 9th divided by a squared, you're left with a to the 7th. And b cubed divided by b squared, you're left with b. So I'm simplified. Okay, moving on, number 17. Now, one thing that's different about 17 is that my whole entire fraction, right? My whole entire fraction is inside of this parentheses, okay? So before I take care of what's in that fraction, or what I'm saying, is inside my parentheses. So when you do order of operations, you say, please excuse my dear Aunt Sally. Looking at what's inside of this very large parentheses, I can simplify that, okay? So let's go ahead and simplify that before we take care of my exponent. It'll make it much easier to do that. So I want to simplify this fraction, 5/10. Now, 5 divided by 10 is not 2, right? You're left with 1 over 2, 1/2. X cubed divided by x is just x squared. And then y to the 6th divided by y, you're left with y to the 5th. All of this is still raised to the 4th power, okay? Now, that coefficient of 1 is unnecessary, so we won't rewrite him, but 1 to the 4th power is still just 1. X squared raised to the 4th, you multiply those exponents. So x to the 8th, y to the 20th, all divided by 2. And that's your final answer. Okay, number 18, very similar. All right, 19, we have a whole lot going on here, okay? We've got this rational expression, this fraction on the left-hand side, or division problem, what you want to say, and then subtracting a term. So I do know I want to take care of that division first, okay? But before I can do that division, I must simplify. That top looks pretty messy. I've got exponents and I have multiplying. So let's take care of the exponents. I'm going to say 4a cubed squared. So 4 squared is 16. A cubed raised to the 2nd is going to be a to the 6th. Multiply those exponents. Then we have times, I'll just write a little times now. 2 squared is 4 and b squared is b squared. All divided by 64. A to the 4th, B, and you know what? I'm going to change this on yours so that it is B. No, that's right. That's what I wanted. The only thing I did, so yes, okay, perfect. So now we've got minus a squared b. Okay. So now let's go ahead and take care of that multiplying before I can divide. So 16 times 4 gives me 64. A to the 6th b squared is the same thing as just a to the 6th b squared, okay? There's nothing I can add there. 64, a to the 4th b, still minus a squared b. Okay, 64 divided by 64 is just 1, so I'll cross that out. A to the 6th divided by a to the 4th, I'm going to write it over here. A to the 6th divided by a to the 4th is a squared. B squared divided by b is just b. So I'm left with a squared b minus a squared b. What's a squared b minus a squared b? What's anything minus itself? 0. That's my final answer. Okay, that was a whole lot of messiness to simplify just to 0. Okay, moving on.